Students, today in this video, we'll discuss the answer key of set 2, 2023 this year question paper, and the question paper code is 55/3/2. तो आपका ये सेट क्वेश्चन आया था, तो आप एक इससे आंसर की मैच कर लीजिए और आप अप्रॉक्सीमेट एक आइडिया लगा सकते हैं कि स्कोर कैसा होगा, और नहीं तो आप कुछ उससे कम आया तो आप ऑब्वियसली अपना जो रीचेक के लिए अप्लाई भी कर सकते हैं। हाँ, तो कभी कभी करेक्शन भी कभी जो करेक्शन होता है तभी भी प्रॉब्लम रह जाता है, तो वो भी कर सकते हो आपका एक्सपेक्टेड मार्क्स से कम आ रहा है। तो मैं आपको दिखा दूँ स्टेप, मतलब क्वेश्चन नंबर 1 टू क्वेश्चन नंबर 18 ये तो 100% सही है, सही आंसर है। उसके बाद डिटेल सॉल्यूशन इस वीडियो में नहीं देंगे। इस वीडियो में ओनली जो न्यूमेरिकल्स होगा, क्वेश्चन नंबर 19 से क्वेश्चन नंबर 35 बोल रहा हूँ, और न्यूमेरिकल्स का अप्रॉक्सीमेट आंसर मैं दे दे रहा हूँ, मतलब ब्रीफ आंसर दे रहा हूँ, और जो जिसका परफेक्ट आंसर भी है उसका आंसर दे दूंगा, बस सॉल्यूशन मैं डिटेल नहीं दे रहा हूँ। और सॉल्यूशन मैं और एक वीडियो में डिटेल वीडियो उसमें सॉल्यूशंस रहेगा, वो कुछ दिन बाद आएगा। पर अभी आप एक आंसर की अप्रोक्सीमेट आप देख लीजिए कि कितना MCQ में ठीक किए हैं और बाकी न्यूमेरिकल्स में भी कितना ठीक किए हैं, अप्रोक्सीमेट आंसर आपका आया है कि नहीं आप देख सकते हैं। अच्छा, तो सेट 2 का जो फर्स्ट क्वेश्चन था, ए वोल्टेज सिग्नल ठीक है, ए वोल्टेज सिग्नल a voltage signal described by V equal to V0, time is in between 0 to t/2, and voltage V equal to 0, time t is in between t and t/2 for a cycle. The RMS value, so root mean square value for this one will be first option, that is option number A is the correct answer, V0/√2। तो आप ये किए होंगे तो सही है। The ratio of the maximum frequency and the minimum frequency of light emitted by Balmer series in Balmer series of hydrogen spectrum, the Bohr model is, तो बाल्मर सीरीज में मैक्सिमम फ्रीक्वेंसी और मिनिमम फ्रीक्वेंसी ऑफ लाइट के बीच में क्या रेशियो है? द करेक्ट आंसर इज 9/5। क्वेश्चन नंबर 3, एट ए सर्टन टेम्परेचर, देखो सेट सी सेट ए भी होगा आपके पास, तो बहुत सारे क्वेश्चन सिमिलर है। सेट सी का भी मैं डिस्कस करूंगा नेक्स्ट वीडियोज में। एट सर्टन टेम्परेचर इन एन इंट्रिंसिक सेमीकंडक्टर, 14th चैप्टर से क्वेश्चन है, सेमीकंडक्टर चैप्टर, इंट्रिंसिक सेमीकंडक्टर, द इलेक्ट्रॉन होल्स कॉन्सेंट्रेशन is 1.5 into 10 to the power 16 meter to the -3, when it is doped with a trivalent dopant, whole concentration increases to 4.5 into 10 to the power 22 meter to the power -3. In doped semiconductor, the concentration of electron, so concentration of electron, the answer is 5 into 10 to the power 9. An infinitely long uniformly charged wire produces an electric field of 18 into 10 to the power 4 Newton per coulomb at a distance 1 centimeter. The linear charge density on the wire is, question number 4, the answer is D. This is the answer, 1 into 10 to the power -7 coulomb meter inverse. Question number 5, at 0 Kelvin, the resistivity of an intrinsic semiconductor is, the correct answer is 0.51 EV. Question number 7. In an experiment of photoelectric effect, the intensity of incident radiation is increased, keeping the frequency nu same. The number of photoelectrons emitted will increase. Option A is the correct answer. Question number 8. The SI unit of mobility of charge carrier is. मोबिलिटी इलेक्ट्रिक फील्ड से रिलेटेड है, तो मोबिलिटी द एसआई यूनिट ऑफ मोबिलिटी ऑफ चार्ज कैरियर इज, तो व्हाट विल बी द यूनिट? बी इज द करेक्ट आंसर. एम स्क्वायर बी इनवर्स एस सेकंड इनवर्स. क्वेश्चन नंबर 9. एन इंडक्टर, ए कैपेसिटर, रेजिस्टर are connected in a series across a source voltage RLC circuit. If the frequency of the source is decreased gradually, the reactance of option B is the correct answer. Inductor decreases and the capacitor increases. Question number 10. In a moving coil galvanometer, the deflecting torque tau acting on a coil is related to the current I following through H. Tau is proportional to I. Torque is proportional to current. More is the current, ज़्यादा current होगा, torque ज़्यादा होगा. More will be the torque. In a wave picture of light, the intensity I of the light is related to the amplitude A of the wave. I A square को proportional होता है. I is proportional to A square. Electromagnetic waves of wavelength of the order of a few meters were first produced and detected in the laboratory by laboratory में first Hodge. Okay, Hodge experiment, HR Hodge. The EMF and the external resistance of a cell are E and R respectively. It is connected across the external resistance R equal to 2R. The potential drop across the terminal of the cell will be, it will be 2 by 3E. C is the correct answer. In a single slit diffraction experiment, the width of the slit is halved. The width of the central maxima in the diffraction pattern will become twice. B is the correct answer. 15. Which of the following graphs correctly represent the variation of the magnitude of the magnetic field outside a straight infinite current carrying wire of radius A as a function of distance R from the center of the wire? So C is the correct answer. This diagram will be most appropriate. Question number 16. 16 to 18, these are assertion region type question. The assertion region, the first option is both assertion region correct. Region is the correct explanation of A. Second option is both assertion and region are true, but region is not correct explanation of the assertion. Option C, assertion is true but region is false. Option D, assertion is false, region is also false. दोनों false है. Last option. तो first question बोल रहा है assertion क्या है? When the radius of the circular loop carrying a steady current is doubled, its magnetic moment becomes 4 times. So, and region is the magnetic moment of a circular loop carrying steady current is proportional to the area of the loop, M equal to IA. तो ये दोनों सही है. तो first option will be for this one option A. So 16 option will be A. That is assertion region correct, and region is the correct explanation of assertion. Now 17. 17 is the nucleus X37 is more stable than nucleus Y34. The atomic number, mass number given, Newton number you can calculate. Region X37 contains more number of protons. So assertion is true, but the region is false. So this will be C. Assertion true, region false. So for 17 the correct option will be C. Then 18. Question number 18. The internal resistance of a cell is constant and reason is ionic concentration of electrolyte remain same during the cell during use of a cell. So assertion is false, reason is also false. So this is option D. 18 option D. Now 19. How the width of the depletion region of the PN junction diode affected when forward bias, reverse bias? Justify your answer. How the width of the depletion region of the PN junction diode. So PN junction diode, forward bias, reverse bias, what happens to the width of the in case of forward bias, in case of reverse bias? So width decreases in forward bias, P side connected to P, N side connected to N. Reverse bias, current flow will reduce. So here depletion region will increase in reverse bias. So we will explain this thing. This will be 2 marks. Explain the property PN junction which makes it suitable for rectifying the alternating current. Differentiate between half wave, full wave. So you can draw the diagrams for half wave and full wave, or you can also explain that in half wave one direct diode is there, in full wave 2 diodes are there. And this is draw a graph showing a graph showing variation of binding energy per nucleus. The binding energy per nucleus is a heavy nucleus decrease with the increase in the number. So the graph will be like this. Okay, here the number will be there, and here okay, no, this is draw the graph between the variation of binding energy per nucleon and the mass number. So this graph will be a little bit different. So this graph, this one, binding energy per nucleon like this iron, this graph will continue, then it will be like this. So this will be the graph. Yeah, binding energy per nucleon and your mass number. So we will explain this. This is not the graph. This is a graph in set C. Using Bohr's postulate, you will explain, derive the expression of the nth. You know that from Coulomb's law and from the centripetal force you will start, and also will take MVR is equal to NH by 2 pi from Bohr's theory. Then you can just equate and find out the radius. So it's there in the NCERT. You can find out 2 marks. The term displacement current, briefly explain. Displacement current, in between two capacitor, the displacement current comes up by d phi by dt, change in flux. So it's generally the varying field creates varying flux create this current. So IC is the conduction current due to the flow of current in a conductor. So these are the difference you can write. 2 marks. 2 wires equal length, equal shaped form, square loop and the circular loop. Both loops are suspended uniform magnetic field. Prove that for the same current, the circular loop will experience the larger torque. Okay, M torque. So you can find out. One square will be there, and another one is your circle. So circle, you will find circle area will be more, so torque will be more for the circle. So the answer will be your torque for circle will be greater than torque of, you will just prove it, torque circle will be greater than torque square. Huygens principle and the absence of the back wave. So Huygens principle, you know, the wavelet will be formed. So all this the theoretical explanation there in the book, you can find out. Use the Huygens principle, reflection and refraction of a plane wave, concave mirror and convex lens. Use Huygens principle to show the reflection or refraction of a plane wave by concave mirror and a convex lens. So a plane wave will take, and concave mirror we will take. Okay, so reflection you will so plane wave, when it will strike, it will form like this, and for convex lens, you know the diagram. Convex lens will be like this, and the plane wave will become incident, so the image will be formed like this for convex lens. This is the plane wave incident. So these things you know. The refractive index of two media A and B, 2 and root 2, a critical angle. So critical angle will be root 2 by 2. We can calculate detail sine inverse. Sine inverse, this will be your critical angle. Okay, sine C equal to root 2 by 2, and C equal to sine inverse, so 1 upon root 2, so 45 degree will be the answer. 45 degree. Now next question. A particle of mass m, charge q, accelerated through the potential difference v. Plot the de Broglie wavelength lambda associated with the function v. So lambda is proportional to 1 by root v. V will be in the denominator. So the graph will be like this. Then calculate the energy acquired by the de Broglie wavelength, so that electron accelerated through the potential difference. So you will use the formula. And find out that the wavelength will come up. The answer is lambda will come up as 0.61 if you have done into 10 to the power minus 10 meter. This is the answer. Okay, so you will use the formula. Your lambda equal to 2m h by 2m k root over. That formula you can start with. 27, question number 27. AC source is given, so the direct derivation is there, and current versus omega t graph is also there in your NCERT book. Oscillatory graph will be there, current and omega t, and the expression also there, so you can draw it. Okay, you can draw it. So current versus omega t, current will come like this, and oscillation will be oscillatory. The series combination, so LCR circuit series combination is given, so you have to calculate the power, and you have to write for a inductive, find the power factor for a purely inductive and purely resistive. So power factor for purely inductive, you will just derive power expression there in the book, and you have to find phi is pi by 2. For purely inductive circuit, and phi will be equal to 0 for purely resistive. For purely resistive, it's phi equal to 0. Phi equal to 0 for purely resistive, and for purely inductive, phi will be equal to pi by 2. So these are the solution for this question. Now next question is prove the nuclear density for. So density you can prove mass per volume. Draw the plot of potential energy pair of nucleus at the function of their separation. Draw the inference. So the graph will be like this. Here the graph will be like this, and this one will be your R0 point. and you will write it to conclusion. Then the next question, discuss briefly to conclusion. Okay, so you will write any to conclusion from this. A rectangular loop of side 25 centimeter and 20 centimeter lying xy. So B is given. So you will find where B is in Tesla. The resistance of the loop is given. Find the EMF induced and the induced current. Induced EMF and induced current. So phi equal to B dot A. So B is given. So you can find area. So B dot A you can find out, and you can find out phi. And here you can find out the EMF, induced EMF. You know, once you find out phi, so d phi by dt you will differentiate it, and you will find out the EMF. So once you get the EMF, you can find out the current. Current will be EMF by R. R is given. Now question number 30. A potential difference V is applied across the load resistance. The current flows. Draw the plot of variation. So power P is equal to V square by R. So V square by R, if we will draw P and R graph. So P and R graph. So V square by R. So R is in the denominator, so it will be like this, the graph. Then P equal to I square R. So P is equal to I square R. If we will draw the graph P and I, so P and I is increasing one, I square. I is increasing one, so it will be, the graph will be increasing. And VR graph, P and V graph, P equal to V square by R. So P and V graph, P and V graph, this is in x-axis, y-axis P, and this is V graph. So this graph will be P equal to V square. So this one also will be same. PI and PV are almost same. So if you have drawn like this, you will get the full marks. Now question number 31, a long question. So these questions are direct there. The derivations are there in the book, so you can derive. I am not doing it in detail. So galvanometer question, you can working of a galvanometer there in the book, you can do it. Magnetic, why magnetic field is radial, so also it's written. Derive the expression for magnetic field in the axis of the current carrying loop, it's also there in the book. This is the current carrying loop, and on the axis you have to find out dv sin theta cos theta. You can do and integrate, and you can find out. Perpendicular component will be cancelled out. Write the two difference between paramagnetic and diamagnetic. So this is two, so you can write the differentiate, at least 2 points you can write. And 32, question number 32. Question number 32. Question number 32, the real image will be formed. Draw a ray diagram showing the formation of a real image of an object placed U in front of the concave mirror of radius R. The concave mirror real image will form. So this is concave mirror. You can place the object. So parallel ray after this, it will strike, it will pass through the focus, and another ray you can draw, pass through focus, parallel. So this will be inverted real image will be formed at the left side. Then you have to calculate the magnification and the you have to derive the equation. Also you have to derive using your similarity of triangles. You can derive it. Then you have to find out. Second bit, height is given in front of a convex lens, so you will use the lens formula, and focal length given, distance given. Find the position and height. So the position will come up with 5 by 4 meter. V will come up as answer, you check, it will be 5/4 meter the B, and the magnification will be M will be 1.25. Draw the ray diagram of the light for a triangular glass prism. So glass prism also you know, this one the derivation you know, sin A plus dm by 2 by, so that derivation you have to do along with the diagram, proper diagram. So finally you have to derive sin A plus the deviation by 2 by sin A by 2. And also you have to solve this problem. The radius of curvature, concave lens are given like this. Refractive index of the material is this one. So you have to find out the radius of curvature. So you can use the lens maker formula here, and you can find out the refractive index will come up as 1.5. You just try to find out using the lens maker formula. Did you define flux and write it SI unit? So you can write flux SI unit is Newton, E by flux is E dot A. So Newton Coulomb inverse meter square. SI unit flux definition. Gauss law to obtain the expression for the electric uniformly charged plane sheet. So you can find out, and this numerical is also given. You can find out region, find the net charge enclosed by Q. Electric field is given like this, AX plus BI cap. Now B, or define electric potential at a point and SI unit. So you can write capacitor are connected in series. You can write the expression, derive the expression, not write the expression, you have to derive it. 1 upon C1 plus 1 upon C2. Then one question is given, numerical. So its answer will be, if we solve it, the potential energy. So the charge will come up. The answer will be, charge will come up as 12Q by 5. 12Q by 5. Try to solve it. I'll discuss with you the detailed solution. 34 the diffraction, how the width of the central maxima affected the wavelength. So width will increase, central maxima, the wavelength also will increase. Then the path reference, the condition of minima is lambda A theta equal to lambda. A theta equal to lambda. This is the condition for the minima. You have to write. Point of diffraction, interference diffraction, you can write interference single, double, so at least 2 slits are required. Diffraction single slit, and also you can write the patterns. Their fringe width are equally spaced. Diffraction central maxima is there, then the gradually the pattern, the central the brightness decreases, intensity decreases. So you can write these differences, at least 2 difference you can write, 2 marks. 2 students separated by 7 meter apart fall in a room 10 meter high. If the light and the sound both bend around the obstacle, how is it that the students are unable to see each other even though they can converse easily? Okay. So also this one you can write. So here the slit opening is which is 3 meter, which is the order of the wavelength of the sound waves is very large as compared to the wavelength of the light. Hence the sound can bend around the obstacle while light cannot. Okay, so you can write the explanation. Now question number, this is what, question number 34. I think last question is missing. Last question also there, which is based upon a, like 2 lines are there, 2 plates, charge plate, electric field is there, and from the middle one charge will move. So how much time it will take? right? So 35 first question answer will be 10 to the power minus 9 second, and B option will be the path will be parabola. This is question number 35 answer. Parabola, this charge will move like this with a potential parabola, follow a parabola path. And third on answer of this 35 will be the voltage you have to calculate, which will be 568.75. 568.75. Okay. .75 volt, and or C or will be 35. 1.9 into 10 to the power minus 3 Tesla. The answer will be or 1.9 into 10 to the power minus 3 Tesla. So this is all about the answer key. You can try it. If any question you are not able to solve, or you think that the answer will be different, you can write in the comment box. I'll also come up with a detailed solution. This is the answer key, and which is authentic, and I will not find any error. But still, if you think that some question that I gave some answer which is not, you are not satisfied, or you think that different answer will be there, so you can write in the comment box. I'll discuss later. So this is all about set B, set 2. So if you are having this set, so match your answer key. And many questions are there in set 3 also. Same questions are there, only few questions which are changed. I'll come up with a detailed solution for the set 3 and set 3 also. Set 1 I'll say, if both the sets are completed, set 1 also be same, right? Okay, thank you for watching. See you in the next video.